Section 5.1, the unit circle. The unit circle is a circle with radius 1 that's centered at the origin. So it's the equation x squared plus y squared equals 1, because the radius is 1. So it goes 1 unit every direction, so it touches all 4 of those points. And you can also find other points by plugging them in for x and y. You can test to see if a point is on the circle. So to show that square root of 3 over 3, square root of 2 over square root of 3 is on the unit circle, plug them both in. X squared plus y squared equals 1. So show that square root of 3 over 3 squared plus square root of 2 over square root of 3 squared equals 1. Show that that's true. So squaring just means we square the top and the bottom, so that's 3 over 9. And square root of 2 squared is 2. Square root of 3 squared is 3. 3 over 9 is 1/3 plus 2/3 equals 1. So yes, that is a point on the unit circle. Now it says the point square root of 3 over 2 comma y is on the unit circle in quadrant 4. Find its y coordinate. So first, let's just recall, here's our axes. This is quadrant 1, 2, 3, and 4. So in quadrant 4, our y value has to be negative, our x value is positive, which it is. So our y value has to be negative. Keep that in mind when we're solving. So now let's plug it in and solve. Square root of 3 over 2 squared plus y squared equals 1. Square root of 3 squared is 3. 2 squared is 4. Plus y squared equals 1. So subtract 3/4 over. 1 minus 3/4 is 1/4. Since it's y squared, we have to square root both sides. And when you square root, it could be positive or negative. So we have y equals positive or negative. Square root of 1 is 1. Square root of 4 is 2. So positive or negative 1/2. And then like we set up here, y has to be negative, so y equals negative 1/2. Now, it makes sense that there be two values because circles have lots of symmetry. They're symmetric across the y-axis, over the y-axis, also over the x-axis. There's all sorts of symmetry. So for a given x value, you could think about it as every point on that line, there's two intersections right there and there. So there's going to be a positive y and a negative y. You could do the same thing if you think about if you had a given y value, there'd be two x values that match it, a positive and a negative. And that also comes about because everything's squared. When you take square root, it has to be plus or minus. But it's also because of the symmetry. Now, all of those points that are on the unit circle, those are called terminal points. And those are just the points that are on the circle. And when you're talking about terminal points, you're talking about somewhere on the circle. And you refer to a value of t, which tells you how far you're going around that circle. Now, since it's a unit circle, the radius is 1, which means the circumference, which is given by 2 pi r, 2 times pi times the radius, which is 1, so the circumference would just be 2 pi. And the value of t just tells you how far around that circle you're walking. So you could kind of think of it as if you had like a tube or something that was very, very thin, and there's an ant crawling around that tube, around that circle. How far would they walk? So t is how far they would walk. Walking counterclockwise is positive, and walking clockwise is negative. Clockwise is negative. So what that means is, if we said we went a value of t as 2 pi, you're going to start, this is always where you start, at 1, 0. And then imagine walking around that circle. If it's positive in a counterclockwise direction, so if we were walking around a value of 2 pi, we would end up back at where we started at 0.10. T is 2 pi, our terminal point is 1, 0. So if we walked a value of half of that, half of 2 pi would just be pi, we would end up going halfway around the circle. So we would end at negative 1, 0. That would be our terminal point. So that's half of a circle. So if you wanted to go, think about it a little bit backwards this time, if we only wanted to go up to this point, 0, 1, then we're walking half of that, which would be half of pi. We'll write that as pi over 2. So when t is pi over 2, we'd end up at 0, 1. And we said if you want to go in a clockwise direction, you just say it's a negative t value. So if we went negative pi over 2, we'd be going in a clockwise direction, pi over 2, which would be 1/4 of the way around. We would end up at 0, negative 1. And you could also get there by walking around counterclockwise, going all the way around this way, which is 3/4 of the circle, so 3/4 of 2 pi, which will be 6 over 4, or 3 over 2, 3 pi over 2. So 2 values for t, 1 positive, 1 negative, that get you to the same place. You could also say maybe you go around more than one whole time. If you went around 4 pi, you'd make 2 circles around, but you still end up at 1, 0. Or 6 pi, you'd still end up at 1, 0. So just subtract about multiples of 2 pi to find out where you end up at. The book doesn't introduce this term yet, but I think it makes sense. This value of t is actually related to what's called radians. And radians are kind of like degrees. It's just a different way of measuring an angle and things like that. So this pi over 2 radians would be like 90 degrees. Pi radians would be like 180 degrees. Your author doesn't introduce it until chapter 6, I think, but I'll give you a little bit of a sneak peek, because I will likely slip and use the word radiance, and now you know what I'm talking about when I say radiance.